Hi everybody. In this video we're going to talk about how we can convert between radians and degrees. So in the last video we saw that when we're measuring angles, sometimes we measure them in radians and sometimes we measure them in degrees. And so since we're using these two different units to measure angles, it's much to our advantage to understand how do we convert from one to the other. And so what we saw when we looked at circles was that one circle, or the unit circle, has a circumference of 2 pi. And so if I go all the way around the unit circle, that means what I've done is I've traveled a distance of 2 pi radians. So I'll write this as 2 pi rad here. And eventually I'm just going to drop this rad and just write 2 pi. But since I'm measuring an angle, I know that if I go all the way around a circle, what I get is I get 360 degrees. So what this tells me is 2 pi radians is the same as 360 degrees. So when you think about going all the way around a circle, you get this relationship. To simplify this, what we can do is we can actually divide both sides by 2, and what we end up with is a conversion factor that you probably see a lot, is that pi radians is the same as 180 degrees. Okay, so pi radians is 180 degrees. So this is the conversion factor that we're going to use here. All right. So the question that often comes up is, if I'm in radians, how do I convert to degrees? And if I'm in degrees, how do I convert to radians? So let's go through an example here. Let's take some number of radians, let's say 7 pi over 4 radians, and I'm going to ask the question, how many degrees is that? Okay, so we have 7 pi over 4 radians, and I know that if I come over here, that pi radians is the same as 180 degrees. So what we can do is, if I think about this conversion factor up here in the blue box, right, so if I think about this one clever thing that we can do is to bring all of these over to one side. So if I divided both sides of this thing by pi, I would get that 1 is the same as 180 degrees divided by pi radians. Okay, so I'm going to put the radians in there just so we know. So what I'm going to do, I'm going to take this 7 pi over 4 and I'm going to actually multiply by this conversion factor. So 180 degrees over pi radians, I know that's 1. So if I multiply 7 pi over 4 by this conversion factor, I'm not going to change my quantity, but I am going to change my units. Right? So I have degrees over radians here. So it's not going to change the amount of stuff I have, it's just going to convert it into a new unit. Right? So the way I like to remember this is, if I'm in radians here, so 7 pi over 4 radians, I want to multiply by the conversion factor that has radians in the denominator, because that will cancel out. Right? So let's go ahead, let's take 7 pi over 4, and let's multiply this by 180 degrees divided by pi radians, and see what happens. So it looks like I have a pi being divided by pi, so these things will end up canceling out. Then I can do some simplification. So 7 times 180 divided by 4. We could punch this into Desmos, but let's just think through it real quick. So 4 has a 2 in it, and so does 180. So those are going to come out nicely. And it seems like 180 has more than 1 2 in it. So if I did 180 divided by 4, what I'm going to get is 45. So this is going to end up being the same as 7 times 45 degrees. And if I think about that, so 7 times 40 is 280, plus 35 is 315 degrees. Okay, so in order to convert from radians to degrees, we multiply by 180 over pi. All right, so let's look at one other example here. If I wanted to convert from degrees to radians, there's also a conversion factor that I can use. So let's pick up some degrees here, like 210 degrees. Well, if I were to take my conversion factor, this 180 degrees divided by pi radians, well, what I did is I took this pi and I divided it to one side. But what I could do is I could take this 180 degrees and bring it over, and I would get the same idea, a conversion factor. So let's do that. Instead of 180 over pi, let's maybe consider pi over 180. So let's think about this here, pi over 180. And so my units here, I have degrees on the bottom and the pi, right? So this is my radians up in the numerator. So again, the way that I feel good about this is I'm in degrees and I want to go to radians, and look at my conversion factor. Degrees are in the denominator, and those are going to end up canceling out with these degrees up here in the numerator. And so that's why I feel good about this. All right. So degrees are going to cancel. We're going to be left with some amount of radians. Now we just have to simplify this. Now going in this direction, I really think it's much to our advantage to reduce this fraction rather than to punch it into Desmos. So Desmos will give us a decimal approximation, but if we're going to compare, we're going to think about the unit circle, it's much nicer to have this as a fraction. So I have to think about this 210 over 180. I want to reduce that. And then what I have is I have this pi that's hanging out. Well, 210 and 180, I spent a little bit of time thinking about it, and I think 180 has a 30 in it, and so does 210. And so if I take a 30 out of both of these, I get 30 times 7 times pi on top, and I get a 30 times 6 in my denominator. Right, so these 30s end up canceling out, and my end result is 7 pi over 6 radians. Okay, so this is some examples of converting from radians to degrees, or converting from degrees to radians. So the key here is remembering that 2 pi radians is 360 degrees. Right? If you just think about your circle, that gives you your conversion factor. Right? So pi radians is 180 degrees. And every time I think about the conversion is, what units do I want in my denominator? If you're in radians, you want radians in the denominator to go over to degrees. If you have degrees, you want degrees in the denominator, so they'll cancel out, and then you'll end up in radians. So I hope this helps out. See you in the next one.